Hello, everyone. My name is Joris Peels, and this is another episode of Unpeeling the News by 3dprint.com. So, if you haven't joined us before, essentially this is meant to be a very succinct, very clear, very insightful, hopefully helpful roundup of the day's 3D printing news. And we're going to look at this news and rank it from, kind of by judging it to be the most impactful, let's say. Now, how we're going to judge things for being the most impactful? Uh, we're going to do some things that are going to be obviously the number one stories of the day. Sometimes I think other days we're going to pick something that's maybe just completely a little bit unknown that we haven't heard about or we won't really consider because the implications maybe are a bit more interesting than we might have thought or impactful than we may have thought. And a lot of times we'll pick some stuff just to make you think and then think about. So now this is very much a work in progress, guys. We're trying to come up with the best way for you to start your day, let's say 3D printing wise, the top stories you want to know in the most succinct way possible, while still being insightful and giving you enough information. So if please let us know if you need more information. If you want us to cover more stories, right now we're doing about anywhere to 4 to 6 or something like that. But we can also cover stories in depth. Now, at the moment, we're trying to get this to be about 15 minutes to 20 minutes, just about thereabout. Maybe you're like, no, I need it to be less than 10 minutes. So please just let us know if what works for you. We're making this for you, essentially. So today we've got 5 stories for you today. And the first one is Anycubic has a beer can size printer. Now we take our news, by the way, just from 3dprint.com, of course, but we also just from wherever. This is a story that's actually widely reported. We got this one out from Reddit, where the beer they latched onto the fact that it's a beer can size printer. So essentially, it's a 17 centimeters high. That's about as much as a 550 milliliter beer can, so a larger beer can, and it's a micro LED desktop 3D printer. So a very tiny printer, and it's made by Anycubic. It's quite a large maker of desktop kind of vat polymerization systems, and JBD. And JBD is a micro LED display manufacturer. It has a light engine from JBD as well. It's touted as being portable, which I'm not entirely sure I've ever really wanted. Remember, there was a guy walking around with an Ultimaker backpack years ago. It's just not something that I've really wanted. I can understand like ruggedized 3D printers for the military or for maybe people trying to help out in developing countries and stuff like that. I understand that, but just like portable is not something I've ever wanted. I don't see how you can do it with a resin printer either, but it's definitely very small. It's very portable. It can print 10 micron details reportedly, and it has a 20,000 hour lifespan. Or there's a lot of desktop printers that don't have a 20,000 hour lifespan, so that's actually really positive that the micro LED array has that kind of lifespan. So I like this because you imagine you're like a single jeweler and you're hand making your jewelry and using this for casting. You don't need 100 impressions or 100 castings a day. So this may be enough for you. So I think this could be very, very exciting, this kind of form factor. And why this is also exciting is we've always seen things like from lasers to galvanometers to digital mirror devices, these kind of light emitting and projection type technologies that are used in millions of phones or TVs or other display technologies. They have huge impact on our industry because people can use them to make a lot of printers. Like over the years, a lot of people have tried OLED, LED, and a bunch of other technologies to make vat polymerization printers off of. So this is always an interesting space to watch. It's really here. We don't know if this is going to be an impactful printer, but anytime somebody appropriates a new light source to use the printer, it's always an interesting space to watch to see if this is going to become the standard or grow or that kind of thing. The fourth item of news out of our top 5 comes to us from the NIST own I think blog, and it is that NIST, or the National Institute of Standards and Technology in the United States, then is going to give up $3.7 million in grants for metal additive manufacturing. Now, NIST, you might know from the awesome artifact you might use to calibrate or test your powder bed fusion printers. Now, this in and of itself isn't a hugely impactful piece of news, but the reason it's here is the following. Like, if we look at it, Laurie E. Locascio, who's the Undersecretary of Commerce's Standards and Technology and the Director of the NIST, is saying, literally, this is a quote: additive manufacturing offers advantages such as reduced material waste, lower energy intensity, reduced time to market, and just-in-time production that could bolster supply chains in the U.S. Accelerating the adoption of new measurement methods and standards will help to advance U.S. competitiveness in this important industry. Now, I think what's really exciting about this is uh, um, uh, the director of the NIST here and NIST is really giving us a kind of a U.S. government mantra, and we've seen this come back and away. And I like the way that it's very clear. I like the way that I've seen these things come back again and again and again. Reduced material, lower energy, reduced time to market, just-in-time production, bolstering supply chains. And this seems to really be like there's a growing kind of reverberating kind of echo in the U.S. government where they keep saying these same things. And I think that this is really hitting home with them, and it really seems to resonate with them, these kind of claims and these kind of things. So to me, this is a significant story because, well, two things. One is this is the messaging of the United States government, which is getting much more on point and much more succinct. And we'll come back to that later again in another story. And grouping around these topics, right? And I think that's very exciting to see that consistency emerge. And that's also something that you could use to your advantage if you're an American company. Now, the other thing is that the way they're framing this is in lockstep with the American media, which is actually the second story we're doing, which is a happy coincidence, one would say. And the other thing that makes this very interesting is the fact that well, the things they're doing, the things they're giving the money to is really kind of interesting. Like two of them, or one of them is enhanced non-destructive evaluation techniques that can determine key material properties such as oxide thickness, splatter particle percentage, and grain size, and defect detection, for example. Or this piece of research that they're funding from Auburn, which is a data-driven framework with computer vision and machine learning for the non-destructive qualification of AM materials and parts for applications that cannot afford failures during fatigue. Now, we all know that fatigue properties, especially for metal 3D printing and long-term fatigue properties, are very difficult to figure out. 3D printing, I've gone on the record saying that I'm very uncomfortable with 3D printed metal 3D printed parts being used where they're under stress. But definitely, I think we can all agree that finding out where your safety envelope is and finding out how this thing needs to be designed and qualifying this thing, and finding out if it can withstand these load cycles and things, is a very, very difficult thing. So this piece of research, definitely the Auburn piece of research, seems like a very, very welcome thing indeed. That could really be a force multiplier for a lot of people. Another thing, this is the number 3 news thing, and it has a lot to do with the number 4 one, and this is CNBC looks at 3D printing again. So what we've been seeing is the mainstream media has been kind of out of love with this for a while, and now we're back, but a little bit differently than before. So the CNBC article is the Economist did an article, and the New York Times did one, a couple other publications have done one, and essentially they're all saying the same thing: 3D printing was overhyped. Right. But now there are applications that are working, and 3D printing is still small, but it's the future. So this is very much kind of like an emerging from the trough kind of communication if we're looking at kind of like a Gartner or hype cycle kind of way. And if we look at it, the story from The Economist, which is about Surat, the story about other stories that have been coming up, they all have the same refrain. And really the media is giving us another chance. Now, the interesting thing about this is that it's very application focused and it's very realistic, and they're not being stupid about it this time. So it's really nice. So, for example, the CNBC story talks about Goodyear opening a plant in Europe where it's using 3D printing in its tire manufacturing, and this tire it really tested airless tires. It's saying that industrial companies like Boeing, GE, Caterpillar, and Cummins are using 3D printing more often. It takes advantage of Hometown Products, which is a Youngstown-based company that's been using 3D printing since 2014 to make cores and sand molds and things. So that's it's all real realistic stuff. It's not like all the skateboards will be 3D printed in the future. Look at this guy who made a skateboard. But it's realistic, it's application focused, it's business focused. So this to me tells me that if we want to penetrate the mainstream media, we need stories of an entrepreneur doing something in America, doing that thing well, using 3D printing, and it's a real realistic, down to earth kind of thing. That seems to be the way to get their attention this time around. And I'm really happy with this. I'm super happy with this. I couldn't be happier with this. None of this, kind of like pie in the sky kind of stuff. Realistic and down to earth. I like it a lot. The second story out of our top 5 stories is, well, it comes to us from a Eureka alert, but we got it. Like, there's a ton of people that wrote about this, a ton of people that will write about this today if they haven't already. Rutgers to make faster, more precise material extrusion possible. So this is a paper that came out from Rutgers University about a multiplexed fused filament fabrication called MF3. No, that's not going to be confusing at all. Anyway, because our official file type is called 3MF. Why would you? No, why? Anyway, so the Rutgers team here has developed a 3D printing kind of refinement, I guess, which is a single gantry stationary build platform, multiple small nozzle 3D printing technology. Now, the idea is that what they claim first is that they increase the resolution, the speed, and the size of parts that are to be printed. Now, this makes me intensely skeptical, of course, because doing these 3 things at once is going to be very, very difficult, of course. But and also the first thing you're thinking, oh, this is like Stacker, right? It's like there's one of these things that just like you print the same copies of the same part simultaneously, and that didn't work, did it? No. What they've done is essentially they've looked at maybe the toolpath efficiency through the slicing, all right, and they've looked at the thermal degradation, the heat history of the print. And what they say in the paper, the most succinct way is MF3 prints concurrently with multiple extruders without controlling each extruder motions individually by using a new toolpath strategy that is rooted in our discovery of continuous filament retraction advancement. Now, so what they seem to be doing is to be directing these nozzles at certain parts of a larger structure, or even certain parts of the same structure, or certain different parts where they print, while controlling for under and over extrusion and retraction continuously, and to have the best continuous output. I think that's very nice. So I've yet to prove it out completely, but this could be very, very, very promising. The other thing that is that they say they can discard nozzles, like the nozzles can be made redundant and replaced during the printing process by making one redundant. I like that. Could be interesting. And of course, you could see that if this could be possible, you could make many nozzles printing the same object simultaneously, or maybe even subsequently, and that could of course be a big advantage. The other reason I really, really like this is because we saw a couple of years ago that, around 2009 or something, everybody believed that stereolithography or vat polymerization, it was dead, right? Now, at one point, there was so much interest in 3D printing that a lot of polymer chemists and scientists and things went and looked at it. And that's when we got carbon. That's when we got like innovations from Henkel and new ways of polymerizing parts and stuff like this. So I hope that something similar happens here, where a lot of people are going to be looking, software people, geometry people, are going to be looking at these toolpaths that we do and trying to solve this to kind of like for more efficient deposition. I think that would be really great, and we see a lot of software innovation. So I don't know yet if this Rutgers innovation is going to be this MF3 stuff is going to be the be all end all, but I'm very, very hopeful that this kind of inspiration will lead to more people looking at the software and how to optimize it and how to optimize flow. We've seen, like, for example, full control, which is a way to control flow on your G code. And we've seen this software like that. That's very powerful. That can let you kind of like edit your G code to optimize for a particular object or toolpath, and that kind of thing. We're seeing more powerful tools, especially if you're going to manufacturing. Right now, we're making printers that are going to make everything more efficiently. Right, but if I'm doing manufacturing, I'm probably going to be printing a whole bunch of pipes or a whole bunch of the same shapes or similar shapes the whole day. So maybe I just want to optimize for that particular geometry. Right. So these kind of things, these kind of ways of thinking, I think are very helpful. And the number one story of today is Relativity Terran H to launch commercial Mars lander in 2024 or maybe 2025. So Terra, Relativity Space, they're the people that have the giant Stargate metal printer. And they're working on the Terran 1 small lift launch vehicle, and also working on because that's just not enough a challenge for these guys, they're also working on the Terran R fully reusable 3D printer rocket. That in turn is going to launch a other startup called Impulse Space's first commercial mission to Mars, and and Impulse Space's Mars cruise vehicle and Mars lander will be aboard the Relativity Space rocket. And they hope to launch that from the Cape Canaveral Space Force Station, SLC-16, which is where Relativity's home there. And they hope to include some payload capacity needed to support the research and development required for future crewed mission to Mars, kind of a base station to maybe do some stuff. So that's very exciting. Again, with these kind of things, you never know how much is going to be true and how difficult it's going to be, or maybe it'll be much more expensive, much more complicated, etc. But this is big news because this is going to really excite people. This is going to interest people. We're already the default. I said it yesterday. We're probably 3D printing's biggest market is going to be in space and space propulsion, in space propulsion, and just making rockets and parts for rockets and things like that. It's going to be a huge chunk of our business. So this is this is something like commercial mission to Mars. That's something that I think nobody would have thought valuable a couple of years ago, except for that one that failed. That was like utterly ludicrous. But apart from that, I think the idea of sending a commercial mission to Mars is, completely crazy a couple of years ago. So this could really capture a lot of people's imaginations, and investors, lawmakers, and all sorts of people like. So these kind of things can really mean a lot for us. So this is our top 5 today. I hope you enjoyed it. I'm going to put the links to the stories in the into the cast now, hopefully. Okay, I'll do that in a little bit. I'll do that here. And then, yeah, I'll put that in the thing later. It's not working at the moment. Sorry about that. But I'll put that in the cast in a bit. And then you guys can, hopefully enjoy this, and hopefully enjoy looking at the stories a little bit more in depth. Again, let me know what you want changed, how you want us to do this, and thank you so much for your time today. This is Unpeeling the News, Unpeeling the 3D printing news with Joris Peels and 3dprint.com. Thank you so much.